Good afternoon and welcome to Mathematics IGCSE. We're working today through exercise 511 and 512. But before we start, some comments on the previous exercise. Sometimes when you do a calculation, you will get an answer as a decimal. Okay? Suppose you get an answer 6.72 hours. And they asked you to write it in hours and minutes and maybe even seconds. How do you do that? Well, these are hours. So it's 6 hours. And 0.72 hours is how much? It is 0.72 times 60. Gives you gives you 43.2 minutes. Okay, so we got 6 hours, 43 minutes, and 0.2 times 60 seconds. 0.2 minutes. How many seconds is 0.2 minutes? It is 60 times 0.2 is 12 seconds. So this is 6 hours, 43 minutes, and 12 seconds. Okay? So if they ask you to work it out in hours and minutes, then you leave it as 43.2 minutes. But you might need to work out the 0.2 minutes as seconds as well, which will give you 12 seconds. Okay. So moving on now to exercise 5.11 or 5.11, which is the last part of percentage. Exercise 511, we're going to work out question 1. We've got 20% of an amount, okay, and they want to know that, and they say 20% of that amount is 35, okay. What is 100% of the amount? They do this as an equation. There's many ways to do this, but we're going to follow the book and they're doing it as an equation. So we're going to write what we say in English in terms and interpret it in terms of an equation. So 20% of what? We don't know, but let's call it X. Okay? 20% of the amount, the unknown amount, is equal to 35. And then we've got a very simple equation. To work this out, all we do is we divide both sides by 20. This becomes 1. And we've got x equal to 35 over 20. You can work that out on your calculator, or you can divide 5 into there, 5 goes into the 7, 5 goes into the 4, and you can work it, you can write it as a mixed number, 4 goes into there 1, and remainder 3, so it's 4 3/4, okay, or 1 3/4, and of course 1 3/4 we know is 1.75. You should know that 0.75 is 3/4. Okay, moving on to question 8. Question 8 of 5.11. This person has been doing exercises and he's reduced his weight by 5%. Now he weighs 76 kilograms. 76 kilograms. He used to weigh more. He reduced his weight by 5%. In other words, if he reduced his weight by 5%, then we've got to know that his unknown weight is equal to 76. And his reduction was 95 over 100. This is reducing your weight by 5%. Multiplying it by 95 over 100. It will be then 5% less. So we just do the same thing again. And by the way, any fraction, if you got a fraction 6 over 11, and you multiply it by 11 over 6, these cancel, those cancel, it's equal to 1. This we call the inverse of that, because we've turned it upside down. So what we can do here is, a quicker way to get rid of this fraction is to multiply it by its inverse, 100 over 95. We can only do that if we multiply this side also by 100 over 95. This cancels, it becomes 1, so x is equal to 76 times 100 over 95, and that gives us 76 times 100 divided by 95 is 80. 80. He used to weigh 80 kilograms. Okay. That's question 8. Question 9. We've got water evaporating from a pond now. And every week, the water loses 12% of its volume. Okay? But the water now is 185 liters. What was the water last week? Well, the water last week was x, because that's what we don't know. And when we multiplied x by less 12% is 88 over 100. Multiplied by x is equal to 185. Okay, so x is equal to 185 multiplied by 100 over 88. See what I've done? I've just taken this and turned it upside down. But I actually multiplied this by its inverse here, and I'm multiplying that by its inverse. So we've got 185 times 100 divided by 88 is 210.2. 210.2 liters. That was in the pond last week. Okay, right. Next. Now we move on to exercise 5.12. And we finished with percentages for a while, and we're moving on to standard form. Standard form, also known as scientific notation. Standard form. Let's just do a few examples, not the questions in the exercises yet. I've just got a few general examples. If we have, and when we have very big numbers or very small numbers, it's very cumbersome to write them with a long, they get too long. So we've got to find a shorter way of writing them. If we want to measure the distance to Mars in millimeters, or if we want to measure the amount of seconds in a year, or if we want to measure the thickness of a blood cell, we need scientific notation because our normal numbers get too long. Okay? So let's take this example of a number of 347,800. Okay? That's already quite a big number, but in terms of scientific notation, it's not really all that big. This is actually 3,100,000 478,000. 3,478,000. So, in the book, they explain to you that the digits move left or right. This is the same as moving the decimal point, except that if the digits move to the left, the decimal point moves to the right. Okay? So I'm used to moving the decimal point. So what I do is I know that we have to write this as 3.47. Okay? And we multiply this by 10 raised to a power. Raised to a power of what? If the decimal point is here, you've got to get back to the whole number. So 3.47 you must multiply by 1, 2, 3, 4, 5, 6 zeros. So that's 10 to the power 6. Okay? That's how I work it out. The other way around, if you have something in scientific notation, 7.894 times 10 to the power of 9. How can we write this as a normal integer? We've got to multiply this by 10 to the power of 9, which means 9 zeros. Or we will be moving this decimal point 9 places that way. Or we will move this whole number 9 places that way. It boils down to the same thing, but I move the decimal point. So 7.894 becomes 1, 2, 3, 4, 5, 6, 7, 8, 9. These are zeros. Each place gets a 0, and there is your decimal point. And after the decimal point is nothing. So this is 7,894,000,000. So these are the thousands. So it's 7,894 million. Okay? You see how cumbersome it gets. That's why we use this form of notation. And this form of notation always has the first decimal point just after the first digit. Not there. Not there, but here. And not there either. Just, it's always here. Right. Moving on to question 3C. I'm just doing a couple of the ones that might be challenging for you. And you can try them all. And if you have any problems other than the ones I'm doing now, please let me know. 3C. 3C is a simplification, 1.5, and I'm not using my calculator here because when we're learning to manipulate something, it's never a good idea to use the calculator. The calculator knows how to manipulate it, but we must learn. So 1.5 times 10 to the 13 squared. Okay? How do we do this? We've got to square each value inside the brackets. Okay? So we multiply this by the exponent here, but the exponent here is, this is supposed to be 10 to the 13. 10 to the 13. We multiply this with the exponent. The exponent here is 1. Okay? Multiply this with that exponent, we get 1.5 squared. 1.5 squared. What is 15 squared? 15 squared, you should know. You should know all the squares from 13, 14, 15, 16 at least. Okay? So work them out every now and then, practice them, and you'll get used to knowing what they are in that way. 15 squared, I know 15 times 15. Okay? I know that it's got to end in a 5 because 5 times 5 is 25. So there's got to be a 5 there. That's a clue. And I know that 15 squared is 225. If you can work this out, it's 225. But there's a decimal point there. And when you're squaring it, there's actually 2 decimal points. Okay? And when you multiply with decimal points, you add the space, you move this up, you count the number of spaces there, there's 2 there, there's a space there after the point, a space there after the point. So it means the point must come here. So that is therefore 2.25. That is 1.5 squared. And we multiply that by 10, and 10 to the power of 13 squared is just 13 times 2 is 26. That is our simplification of that one. All we've done is we've got rid of the brackets. Okay? And you can't simplify that anymore in standard notation. Then we go to 3k. 3k is a fraction. It's got 1.7 here times 10 to the 8. And we got 3.4 times 10 to the 5. Okay? So you know that 2 times 17 is 34. In other words, if you move this point there and this point there, you would have a half. Okay? Because 17 goes into 17 once, 17 goes into 34 twice. So you got a half. And this is multiplied by these two divided. 10 to the 8 divided by 10 to the 5. You subtract the powers when you divide. So it's 8 minus 5. This is 10 to the 3. Okay, but now we have to write this as a decimal to get it into scientific notation. So we know that a half is 0.5 times 10 to the 3. But this is not scientific notation because the point needs to be there. So we're going to move the point there. Okay, no problem. We've moved the point there. How do we move it there? We multiply by 10. But now, because we want to keep this value of this the same, if we multiply this by 10, we've got to divide this by 10. Okay? And then it means that we subtract the powers. So now we've got 5.0 to the times 10 to the 3 minus 1 times 10 to the 2. So it's the same as fractions, same as equations, they're all the same. What you do to the left, you do to the right, what you do to the top, you do to the bottom, then you're not changing anything, okay? That's our answer now, 2, 3k. Simplified. Last one, 4e, number 4e. When we add or subtract scientific notation, there's a couple of ways to do it. We can, I just want to show you the other way first. Let's just bear with me. I want to show you another example. Out of my head, 3.6 times 10 to the 5, okay? Plus 7.9 times 10 to the 6. Okay? Now there's two ways to do this. You can either change this in, and this is what the book recommends. You change this into normal notation, and this, and then you add them together. Okay, so this is 3.6 times 10 to the 5. So if our point was there, it would be 1, 2, 3, 4, 5 plus 7.9, and we've got to move 6. 1, 2, 3, 4, 5, 6. Now we've got to add them together. So what have we got here? We've got 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5. Got to be careful you don't make a mistake with the zeros. 9, 7. Here we got 4 zeros. 1, 2, 3, 4. And then we got a 6 and we got a 3. So we're going to add this up now. Your calculator can do this much quicker than this, but you won't learn much about manipulation. 0, 0, 0, 0, 6, 9 and 3 is 12, and 7 and 1 is 8. Okay? Now we have to change it back into scientific notation. We know it's going to be 8.26. It has to. So, if the point was here, we got 1, 2, 3, 4, 5, 6 times 10 to the 6. And there you are. Okay. That is the way to do it. If that's one way to do it. Now, the other way to do it, which I actually prefer, is to manipulate these so that this 10 to the 6, I always take the biggest one. Not 10 to the 5, but 10 to the 6. I change this to 10 to the 5. How do you do that? Well, you say 3.6, this doesn't change, times 10 to the 5, plus, now we're going to change this. How do we get this to 10 to the 5? Okay, let's write 10 to the 5. What did we do? We divided by 10. Okay? Means that we have to multiply this one by 10 to keep the value the same. Multiply this by 10, we just move the decimal point. So it's 79 times 10 to the 5. Okay? Now because these are of the same kind, this is 3.6 of 10 to the 5 and this is 79 of 10 to the 5. We can just add them. So it's 79 plus 3.6 is 9 and 3 is 12, 2, 31 is 8. Okay? So therefore, the answer is 8.26 times 10 to the 5. Oh. No. 82.6 times 10 to the 5. We have to do a change here. So it's 82.6 times 10 to the 5. Okay? Which is correct because this is all still times 10 to the 5 because we changed it. Now we're going to change it back again to get this point here. So back here. So we're going to divide by 10. We're going to have 8.26. Because we divided by 10, we must multiply by 10 there. So we get 10 to the 6. So our answer is 8.26 times 10 to the 6. This method works very well when your exponents are not too different. So if the difference between this and this is like 1 or 2 or maybe 3, it's okay, you don't have too many zeros. But as soon as it gets more, you got so many zeros, you may as well just convert the whole thing. So you can choose which one you would prefer to do. So we go now on to, having said that, on to for E, which is similar sort of thing. It's 5.8 times 10 to the 9 minus 2.7 times 10 to the 3. And this gets ugly. Why? Because there's a whole 6 different between this and this. So we're going to have a lot of zeros anyway. So we may as well convert the whole thing to normal numbers. Because manipulation is not going to help us that, it's not going to help us that much with the zeros. But we can subtract first the constants. 5.8 minus 2.7 is 3.1. 3.1, oh no, we're not doing it that way. Take the biggest one. 5.8 times 10 to the 9. 5, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 2.7 times 10 to the 3. 1, 2, 7, 2. Is this right? 2.7 times 10 to the 1, 2, 3. That's correct. Now we've got to subtract. Whoa, how do we subtract this? Well, 0 minus 0 is 0, and that's 0. Here we've got to borrow. We borrow from there. When you do that, everyone here turns out to be 9. except the one that you borrowed, because you borrowed actually a whole 10. 10 minus 7 is 3. Okay? This is now 9. 9, 9, 9, 9, 9. Why is that? Because you borrowed 10 here, and then you took 1 away from the 10, and you became 10 here. And then you took 1 away, and this 1 went all the way until it got there. And when it got there, it was 10. So 2 from 9 is 7, and this is 9, 9, 9, 9, 8, 5. And so our answer, now we've got to convert it back. Remember, if we convert back, our decimal point has to be there. So we've got 5.899997300 times 10 to the what? We've got to get, because this point wasn't actually there because we subtracted there. We've got to get from this scientific notation to this whole number here. So we count the steps. 1, 2, 3, 4, 5, 6, 7, 8, 9. Don't forget the 2 zeros. 9. And you can always be sure that this exponent here is going to be, because this is very small compared to that. That's why the exponent hasn't changed. If you get an exponent here of 6, you must know there's something wrong. You've made a mistake. So this exponent here, when you subtract like this, is always going to be 9. Because you've subtracted 1 and 9 zeros from 1, and 1, 2, 3, 4, 5, 6, 7, 8, 9. You subtracted something with only 3 zeros. Very small compared to that. So it doesn't change the exponent much. Alright, well, I hope that's helpful. And if you have any problems with the exercises, please let me know. Thank you.